Okay, welcome back. This video goes along with the work video. This is about force and motion. Hopefully you have your notes from class. If you didn't, you can print them off, the link from my website. And with those notes, these are different kind of notes that we've done before on our videos, so I'm just going to remind you. If it's underlined, you just write in the blank. So hopefully these notes will help you. It's just change it up a little bit. So I've underlined it on my boards, and then it's underlined on your paper, and you just have to fill in the missing word. We've done that in class before, but we've never done it through the videos. So what we're going to talk about force. Last video was about work. So this one's going to be about force and motion and balanced and unbalanced forces. And again, we have to apply all of this to living systems, how living things use forces to do work and to cause motion. It's obvious with us and within humans and other animals, not so obvious with so many with plants. So we're going to try to focus in on our living systems, and we're going to use our beans and our corn in class as an example of that. All right, so force and motion are closely related. In fact, they are always working together. Okay, we know that force is either a push or a pull, and we know the definition of motion is a change in the position of an object. Okay. In order to understand force and motion, you need to understand how forces cause motion. So that's what we're going to focus on here. So push, pause, make sure that you've got all your words in there correctly. And if you, as always, if you have any questions, you can message me right away on Edmodo, or write them in your journal, write them on your questions here on your sheet, and ask me in class. So here we have a definition of unbalanced forces. We talk a lot in science class about balance and unbalance, about, the word is homeostasis. Well, unbalanced forces are forces that cause changes in an object's motion. It's because of the unbalanced forces that we actually have a change in motion. And we're going to talk about that in a little bit. Unbalanced forces are forces that are obviously not equal. So you have greater or forces. So when we have equal forces, we have no motion. These arrows represent equal force. They're skinny lines. They're pushing from both directions on this 100-pound box, and it's not moving. Okay. Here's another example where we have, say, maybe a table pushing up on a 100-pound box with force, and gravity pushing down with its equal force on a 100-pound box. And because the force is equal, that box is staying put, and it will stay there until something happens with this force. Okay, so you might want to push pause, make sure your words are written down correctly, and I would sketch this in my journal because this is going to be helpful to us when we work on these problems in class. So push pause, take care of business, and come on back when you're ready. All right. Here's an example of unbalanced forces. And in the first slide, or the first box there, we talked about, equal forces, those little skinny lines. They were all the same. And now we've got some obvious greater forces working on that 100-pound box. Okay? Or you've got a little tiny table, not very strong, and the force of gravity pulling down on that 100-pound box. And say this little tippy table's not going to stand. So if it's an unbalanced force, it shows the direction of movement. So in this situation, the box would move in the direction of the greater force, and in this situation, the box would move in the direction of the greater force. So an unbalanced force equals motion in the direction of the greater force. I would sketch this in my journal and understand this very important concept, that unbalanced forces cause motion. Now, let's apply this to our corn and beans. Okay, we need motion to happen. We need work to be done. We need those cotyledons to break apart. We need those embryonic leaves to come up out of the soil and open up to the sun. We need that root to force its way down. We need motion. Okay, and so our cotyledons and our embryonic leaves and embryonic stem and embryonic roots have to overcome and have a greater force than the forces that are already working. Okay, so the force of gravity. We're talking about our geotropisms. We take our corn and we're turning it a quarter turn every day. And so we're seeing the result we're seeing is those roots are changing and they're moving in response to that. And the phototropism, the stems and the leaves are growing against this resistance force of gravity, and they're pushing up against it. So the direction of the greater force there, we can talk about that with our labs. So push pause, make sure you've got your sketches made, and come on back when you're ready. All right, a little bit more definition, a little bit more information here, not much more. Forces can cause objects to speed up, slow down, or change their direction. A lot of times we just talk about a force as either a push or pull, and technically it is. Here are some examples of pushes and pulls and forces that can speed up, slow down, or change the direction of an object. Okay, of course we've got number 1 and number 2, always push and pull. Gravity is a resistance force. Air resistance, of course, is also. Friction, and then we also have magnetism. And we're going to talk about that a little bit in class. Maybe not so much, but if you have some questions about that one, we can address that. So, push, pull, gravity, air resistance, friction, and magnetism. So push pause if you need to, get that written down, and come on back. Finally, we're going to talk about friction and air resistance. It tells us that friction is a force that resists or opposes motion of an object. Friction, the best way that we can experience friction, we do this instinctually. When our hands are cold, we rub our hands together and it makes heat. We are creating resistance between our hands. Okay. Friction is caused by two objects that come in contact, and it resists and it makes a little bit of heat. Air resistance is a type of friction. Air is an object. It has mass and takes up space. And so air resistance is a form of friction between the molecules of the air, and the object. We talk about this in class on occasion. We talk about how seeds can use this form of air resistance and the form of friction. We talk about seed dispersal, and we'll have a conversation about that before we're done, but how seeds actually can use this to their advantage when they have, for example, dandelion seeds. They kind of float. They use air resistance to get from place to place on the wind, or how a bird can stay aloft using air resistance. So we're going to talk about some of these things through our classes and through our activities. But these are our basic definitions. Push pause, make sure you have them written down, and then we'll work with these in class on our activities.